In fact, it's softer than the other one. I'm going to cut it. Yeah, it's fairly easy to cut. What's keeping it stuck on here?
Oil.
The oil, yeah. How do you think that reacted compared to the other?
Sizzly.
Did it react more vigorously or less?
More.
More. Now, it was fizzing. I saw some bubbles, but it's certainly not boiling. What do you think, what do bubbles indicate? If something's not boiling, they can also indicate what's given off.
Gas.
A gas, right. Now, the gas comes off so quickly that I can't collect it. Now, what I'm going to do the same experiment again with sodium, but I'm going to float it. I'm going to float that on the water. I'm going to do it on there. Now, that stops the sodium moving around a lot. So more of the heat from the reaction stays there. And if more heat stays there, hopefully, what did I say the bubbles were?
Gas.
A gas, and the gas is hydrogen. And hydrogen burns. Yes? Yeah? What do I normally need to set something alight?
Fire.
A flame. But this produces enough heat to light the hydrogen. So I'm going to repeat that experiment with sodium again. That's why I got 2 pieces. But this time I'm going to drop it on the filter paper, and the filter paper will stop the sodium going onto the water. What does water tend to do to things? If you burn yourself, what should you do? If you burn yourself,
Put it in cold water.
run it under the tap for a long while, yes? Because it cools things down. But this piece of sodium isn't going to be cooled down as much as the other one, because it's not going to go all round the water. It's going to be restricted by this paper.
Ooh. Oh, wow. Ooh.
So do you think that was more reactive?
Yeah.
It was. So as I went from Li, lithium, at the top to sodium, it got more reactive. What's the symbol of the next one? After Na? K. That's potassium. That's potassium. Now, how reactive do you think that will be?
Very reactive.
More so, because as I'm going down, they're getting what? More reactive, yeah? In fact, I could get rid of this. I don't even need that now. What didn't I do? Carry it across the
floor.
In case I dropped anything off it, right? Right, so I've not even got the filter paper on this one. This will be wet. And what have I got to keep these metals away from?
Water.
So I really ought to get that dry, didn't I? So, let's have a look at potassium. Are you alright? That's really soft. Yeah? Yeah? I'm not going to have a piece that big. Right? Make sure it goes down in the wheel. So what are we expecting with this one?
Variations. Fire.
Better.
Fire.
Oh, I'm thinking of another word.
Bigger.
Bigger. Have you come across the word vigorous?
No.
If something vigorous. Wow. So let's see what this one does. I've got no paper to this, so this has got the full run of the water. Like a lilac flame, yes. And the colour of the sodium flame was
Pink. Orange.
orangey yellow. Now, have you seen the street lights? The sodium street lights, sodium vapour there. Yeah? Similar colour, isn't it? So they are 3 reactive metals. That's K. Can you see what 2 letters come before after K? R, B, that's rubidium, and CS, that's cesium. I can't do those in class. We haven't got any of those in school. Why do you think? Go on.
Is it because it's like they'd make up a
It's too...
flammable.
No, it's not as if it catches fire.
Too vigorous.
It's too good lad. It's too vigorous. It's too reactive. Yes. Now, what did I say that gas was? Can you remember that gas that it was actually it wasn't the metal that was lighting. It was the gas that it produced with water that was lighting, and the gas begins with H. Can you think of a gas that begins with H? You put it in weather balloons to send them up into the air. It's a lot less dense than air, so if you like it. Yeah? No. Helium is, you have that in your party balloons, don't you? And if you inhale something, you leave it all on that, don't you? Yeah?
Hydrogen.
It's hydrogen, yes. Because it's a lot cheaper than helium. So for things like weather balloons, it's a lot cheaper. What did hydrogen used to be put in? Have you ever seen airships?
No. Gas tanks or something.
Used to be put in airships. Have you seen them like big balloons? Have you heard of the Hindenburg? When you get home, you can have a look on the research on Google. The Hindenburg. That was a big airship. That they used to fill them with hydrogen, and there was a spark. And hydrogen burns quietly, as you saw. But if you mix it with air, has anybody got any pacemakers or Dickie Harts? No? No? So if you mix this hydrogen with air, BANG! You get an explosion. And this is what happened. It caught fire, there's a big explosion, there's pictures of it, and anybody on the airship, it just sort of disintegrated. And that's why they started filling them with helium, because helium is inert, which means it's not reactive. It's a lot more expensive to produce, but it's a lot safer. Now, so what's this gas that metals react with? Well, these reactive metals react with water to produce this gas. What's it called? Which one? Begins with I, H. See if you get the right one.
Hydrogen?
Hydrogen it is, yes. And if you mix hydrogen with air, and you get a pop. Now, you're going to use a less reactive metal than these. Some magnesium, and you're going to react it with an acid. Now, I want you to follow me because this is how you're going to do it. And at the back there, how many wear spectacles? 1, 2, 3. There are some goggles at the side that you can actually put over spectacles. Now, you'll need one of these tubes. This has got an acid in, so you have to be very careful, and you put it in the rack. Why do you think I did that with this bit of paper? What might there have been on that paper? Some little bits of the metal, yes, and if I'd have just put it in the bin, it's the moisture in your skin. It's the moisture in your skin. Yeah, you've seen all these adverts for these expensive creams that keep the moisture, yeah?
Yeah.
So, if I touch one of those metals with my skin, what do you think would happen? If there's water on my skin, the same thing would happen as what happened, what you've just seen, wouldn't it? Yeah? And I'd really get burnt. So, that's why I've rinsed that to make sure there's no little bits left, so that when the cleaners come, they don't just put their hand in the bin and... So, the experiment you're going to do, I need the Bunsen again for this. I can pull it to a safer distance. Now we've not got any of these bubbles floating about. Oh, it's still on. Now, in there is some acid. When you put this magnesium in, it will do the same thing as what these reactive metals did with water. What gas will it make? Hydrogen. And if I mix hydrogen with air, what does it do? It pops. So, watch how you're going to do it. So we work in pairs for this. I'm going to drop the piece of magnesium in there, and I'm going to put... You won't lift it up. Can you see it? It's reacting, isn't it? Yeah? And I'm going to keep my thumb over until... What's it producing in there?
Bubbles.
Come on, you've told me twice already. It's producing hydrogen. And hydrogen gas will come up here, won't it, and mix with the air that's already there. What's going to happen to the pressure in that tube as this gas is being produced? Is it getting bigger or less? Bigger. So in fact, after a while I can start to feel it starting to push my thumb up. Yeah? How long has this been in now, do you reckon?
10 seconds.
Pardon, 2 minutes?
I think 10 seconds. It's been more than 10 seconds.
Is it reacting slower or faster to start with?
Faster.
It's faster. What had I got on my hands? Some of the...
Moist.
What was those metal in that stick to your hands? Oil, yeah. And that, I'd probably get a bit behind the magnesium. So that formed a protective coating. That's why it's reacting faster now. Now, I'll see if then one person in the group is trapping the gas. So in there, as it's producing hydrogen, I should have a mixture of hydrogen and what? Not just oxygen, but what's in the air? Air. Hydrogen and air. Now, I don't know if that'll be long enough. If it is, so the other person in the group will have a splint. Are you ready?
Ooh, cool.
Did you hear the pop?
Yeah.
Yeah? So, there are tubes of hydrogen there. I shall give you a piece of magnesium that you can take from here. Don't, I'll give you the right length. Right? So when you get it, if you can just sort of fold it up like that. One of the pair will drop it in. As soon as it's in, put your thumb over. How long did we wait, did we say, Lucy? About?
I was going to ask 2 minutes. Ask 2 minutes.
About what we're going to ask. Go on.
I was going to ask how many times would it work with the pop thing?
Well, if it's, well, you wait about 2 to 3 minutes. You should probably just feel a little bit of pressure under your thumb. If you wait about 3 minutes, I'm going to put like some Bunsen burners. If I put about 3 out there, yes, I'll leave them on this flame. This is called the safety flame because you can actually see it. Yeah, I'll put these near the back. So you've got to be careful that you don't. If you've got long hair, you should actually have it tied back. But if you've got long hair, make sure. Yeah. I know you're walking out there looking like me. So
I'm
one
sure
will,
Lucy can just put it in the back of her.
yeah, one will have the finger over there. I'll see if this works again. The other one will come up with a splint. Yeah. So if you've got some magnet, it might work a second time. So you don't have to lift this up or anything. You drop the magnesium in, thumb over. The other member of the group comes with the splint. As soon as you take your thumb off, please, yeah, when you come in with a splint, don't burn his finger or her finger. Wait till they've removed the finger and then just put it to the mouth of the tube. But there's something that you need on for this. Goggles. And you don't take goggles off until all the equipment's put back. Because more accidents happen in science laboratories when equipment's been got out or put back than actually doing the experiment. So, are we all clear what we should be?
Yeah.
Are you absolutely sure?
Yes.
Because we are dealing with chemicals and we are dealing with a hot splint here. Do you understand you're going to have to be very, very sensible and really concentrate?
Now, I shall have, again the Bunsen, I'll have one of these mats. Because if it's really like the splint, if you blow it, what can happen?
It could get like...
You can blow the flame on somebody's clothes or hair. So when you've done your pop test and you've finished with it for the time being, if you just... So he says, yeah? If you just sort of move it round, yeah, it will in time, it will go out, yeah? So don't be tempted to... And then you can just leave it there. But again, don't go pick it up that end straight away. If you do burn yourselves, most common accident in science labs, you don't go and ask the teacher why. The key thing is putting it under the tap straight away. And you don't just go, you keep it under, yeah? So you don't go to, because if you go and tell your teacher, not in this case, but if you touch, say, hot metal, you'll be getting a blister. So, goggles. I'll put the piece of magnesium here. Don't drop them when you carry them to, if you do drop it, don't say, oh well, I'm not know, just let me know, because obviously we don't want this chemicals about. Well, I'm going to light 3 Bunsens. I'm going to put a splint there. Don't pop it in till I've got the Bunsens ready. Then you'll pop it in there. One will have the thumb over. When you've had it in for how long?
2 minutes.
2 or 3 minutes. When you can feel the pressure, you'll Other one, put the hand there and, yeah? So,
Mr Baker, can I just ask for the teachers to make sure that the pairings are right? Are you with me? Okay. And these are the goggles for people with glasses, aren't they?
they're the ones for the ones with glasses, yes. 1, 2. So if